Hello everyone, this is the presentation of SAFE, which is a toolset based on a black box approach for the identification of root causes for DNN failures and DNN retraining. SAFE takes as an input a set of images that led to DNN failures. It performs safety analysis and retraining in 6 steps. In step 1, SAFE generates the root cause clusters. This step consists of 4 activities. In the first activity, SAFE downsamples the size of the images to match VGG16's input size requirement. In the second activity, SAFE relies on a transfer learning-based feature extraction method that leverages the VGGNet16 model pre-trained on the ImageNet database. In the third activity, SAFE relies on principal component analysis to reduce the dimensions of the features. In the fourth activity, SAFE relies on the dbScan clustering algorithm to generate the root cause clusters. The generated clusters contain images that are similar and therefore led to failure for same reason. Step 2 involves a visual inspection of the images belonging to each root cause cluster. This activity is key for safety analysis since by identifying the commonalities across the images in the same cluster, the engineer can determine in which scenarios the DNN may fail. Based on domain knowledge, the engineer can determine the likelihood of those scenarios and their impact on the system. Consequently, he can decide if the system is adequate for production or if improvement is needed. In step 3, the engineer provides a new set of images referred to as the improvement set, which is an additional set of images from which we select a set of images to retrain the model. In step 4, SAFE relies on the generated root cause clusters to select a subset of images from the improvement set called the unsafe set. The unsafe set consists of images in the improvement set that are the representative of the clusters because they are closer to the core points of this cluster. In step 5, the engineer labels the images in the unsafe set, if needed. Sometimes labeling is needed because images comes from the real world, so our approach reduces the cost associated to labeling. Other times, labeling is not needed because images can be generated by a simulator, and in this case, our approach is useful because it enables to select a subset of the available images for retraining, which turns out to be a more effective way to retrain the DNN. Finally, in step 6, SAFE automatically retrains the model to enhance its prediction accuracy. For this demo, we consider a DNN that classifies the direction of the head of a person in an image. Precisely, we aim to determine what are the root causes of this error. We applied the DNN on a test set that includes images with environmental elements that affect the prediction results. We call them injected failure scenarios. For example, a hand on a mouth or blurriness of the image. To generate the root cause clusters using our tool, we first write the path to a folder containing the images that we want to use to generate the root cause clusters. For this example, I use a folder containing images with injected faults mentioned before. Then I click on the Generate Clusters button and we wait for a few seconds. After a few seconds, the root cause clusters will appear in the bottom. We can visualize each cluster as a GIF by clicking on the thumbnail representing it. For example, this cluster failed because the images in this cluster failed because there is noise hiding the face. The images in this cluster failed because there is a mask hiding the mouth in the face. For the unsafe set selection, we switch to the next tab and we put the path to the folder containing the improvement set. In this example, I use the same folder. Then I click on the Generate List of Images and then we wait for a few seconds. After a few seconds, the number and the list of images will appear below. These images can be added to the retraining set to retrain the DNN and improve its accuracy. Thank you.